So we're going to make our table. Now, we aren't going to do the table on our own. We're going to let the calculator tell us what our y is. So let's see. Our equation is f of x equals e to the x power. And I'm going to fill out my table. I want some negative numbers and positive numbers. So -2, -1, 0, 1, 2. Alright, and like I said, we'll have the calculator tell us the rest of this table. Because e is kind of a rounded number, 2.718. The calculator is going to help out a lot. So go to y equals. Alright, so we want e to the x power. Okay. So e to the x is written in blue above that natural log. You're going to press second ln to get this e to the power. And you can put whatever power you want. We went to the x power for this problem. So e to the x power. Once you have that, you want to go to your table. Now, if you remember, we have our table set to go to 1,000,000, right? So we need to change that. We want our table to go to -2 for this problem. So go to your table set, second window. Let's change it to -2. Enter. Now go to your table. Fill out the table on your notes. So second graph. All right. And it shows us our table. So when x is -2, my y is 0.135. -1 is 0.36801. 2.7183. And 7.389. And we're going to plot those points. Just do the best you can. It's going to be a little hard to plot these points. -2.135 is going to be really, really close to that y-axis, or the x-axis. I'm sorry. -1.368 is going to be a little bit higher, but not much. 0, 1, that's an easy one to plot, finally. 1 and 2.7183 is going to be somewhere in here. 2 and 7.389 is somewhere in here. Like I said, just do your best. Okay? And then draw your curve. Okay, so you can see, like, even though, like, we have a base of e, we're still going to have a horizontal asymptote at y equals 0, and it's still going to go through the point 0, 1. So that's kind of cool. And like I said, it'll move up or down if you want it to, if you change that equation. But if we're just talking about a base, like this, a base to the x power, it's going to have a horizontal asymptote at 0, and you'll have a point at 0, 1. Okay, your domain is just like an exponential function. Okay, my domain goes to the left for forever and to the right for forever. So negative infinity to positive infinity, or all real numbers. My range, my y values, goes from 0 to infinity. Make sure they both have parentheses. Okay. Or you could say y is greater than 0. Your asymptote, we said, was y equals 0. Okay, and then some characteristics. Okay, for this graph, if we look at our x from left to right, my y is going to be increasing. It's going up from left to right. So we say f of x is increasing. And another characteristic is that we have a horizontal asymptote at y equals 0. Last part of the notes, we're going to actually solve some exponential equations. And they tell you if e to the n power equals b to the n power and n equals n. Basically that's saying if you have the same base on both sides of the equal sign, then your exponent should be equal also. Okay, basically like if I had 2 to the third, then this would be 2 to the third also. They're equal. So it's kind of self-explanatory. But the problem happens whenever you don't have the same base. So like let's look at number 1. 2 to the third times 2 to the x equals 16 to the negative x power. Okay. So I have bases of 2 on the left side, and on the right side I have a base of 16. So I'm going to have to try to get this 16 to be a base of 2 if I can. And you actually can. So 16 would be 2 to the 4th power. And you can kind of like put in your calculator 2 squared and see what you get. 2 cubed, see what you get, until you get 16. But we're trying to get all of these to have the same base. Okay. So this is going to be on the left side. Since we're multiplying, we're going to add our exponents. Okay, we're still using laws of exponents to solve. So 2 to the 3 plus x equals 2 to the 4th is what that 16 is. So 2 to the 4th to the negative x power. Okay. So that 2 to the 4th replaces the 16. And I still have the negative x power outside here. All right, so now we're going to solve this. Since we have the same base, that means our exponents are equal. So this 3 plus x is going to equal, let's see, if you have a power to a power, you multiply them. So it's going to equal negative 4x. We're going to multiply them together. Okay. All right, and now we're going to solve for x. So to solve for x, you need your x's on the same side. So let's move this x to the right. That way they're over to the right side by themselves. So subtract x, do that to both sides. So 3 equals negative 5x. Okay. To get x by itself, I'm going to divide by negative 5. So x equals negative 3/5. All right, let's look at number 2. We have 8 to the x squared power over 4 to the x equals 2. Now, we can't just divide 8 to the x squared divided by 4 to the x because they aren't the same base. Okay, so we're going to have to get the same base on all of these if we want to actually solve for x. So 8 is the same thing as 2 cubed, and then to the x squared power. 4 is the same thing as 2 squared, and I have it to the x power. That's going to equal 2. Okay, so my first step is to get everything in the same base. All right, then I'm going to use laws of exponents to simplify this, kind of condense it. So we have a power to a power. We're going to multiply those together. So it'd be 3x squared over 2 to the 2x equals 2. And if we're dividing, we subtract our exponents. So we would have 2 to the 3x squared minus 2x. We're subtracting those two. equals 2. Now here on the right side, this is like saying 2 to the first power. Okay, there's a sneaky one. Alright, so now that we've condensed it, we have the same base. Our exponents are going to be equal to each other. So 3x squared minus 2x equals 1. And we're going to solve for x. Okay, so do you see how this is quadratic? You have an x squared here, right? To solve a quadratic, you either use complete the square, factoring, quadratic formula, all those methods we learned a couple months ago. We can't forget what we've learned all year. It's going to keep coming back. Okay, so we need to get it to equal 0. So we're going to subtract 1 to both sides. So I have 3x squared minus 2x minus 1 equals 0. And you can pick whatever method you want. I'm going to pick factoring. So I'm going to multiply the first times the last. 3 times negative 1 is negative 3. And I'm going to find the factors of 3. In order to get negative 2 in the middle, I'm going to have 1 and a negative 3. Okay. So I'm going to bring down my 3x squared, and I'm going to split up my middle term into what I just figured out. Okay, 1x and negative 3x. And then my last term will just come down. Okay, now we're going to group the first two together and the last two together and see if they have anything in common. So the first two, they have an x in common. So I'm going to take out an x, and I'm left with 3x plus 1. My last two have a negative 1 in common, and I'm left with a 3x plus 1. If you don't get the same binomial in both of these, you did something wrong. Okay, so you need to go back and check. So this is telling me I'm going to have x minus 1 and 3x plus 1 equal to 0. Now, this first factor, this is kind of the easier one because you don't have a number in front. It's just a sneaky 1. So x would be positive 1. Okay, on the second one, we're still going to do the opposite, but we're also going to divide by the number in front. So negative 1/3. Okay, so if you remember the trick, you can do that. Take the opposite and then divide by the number in front. If you don't remember that trick, it's not a big deal. What you can do is set each factor equal to 0 and solve for x, and you'll still get the same answer. Okay, 3x plus 1 equals 0, solve for x, divide by 3, and I still get negative 1/3. So don't be scared if you forget the trick. Just set it equal to 0 and solve for it. Okay, so let's try number 3.